So this is the process of how to install R. Everything is given in your textbook. Okay. So there are main four windows in RStudio. So there are four main windows in RStudio. I'll open one. So this is script window. Script window is helps to store our codes, and in future if you want to run the same code with a different data set, means you can save it in you can type your all the codes, all the functions here, and save it in a particular date. You can use it again. So the script is very helpful when you are doing the same analysis with the different data in the future. Here it's a console. Whatever we have written here, if you run, you will get the result output in this window. This is the environment window. Here, what are the packages? What are the things we are running? The history will come, and here it's a package details. If you want to install any packages, you can install using the package. And if you know the package details, package means what package? If I want to run some function, like addition, subtraction. So all these things will come under one particular package. That package, you need to type it here and install it and run the library. If you want to run the linear regression, means there is some package for the linear regression. For repeated measures ANOVA, there's some package. So these the function which combines all the execution commands, that is called package. Okay. And if you're running the graph plots, visualizing that data, means it will come this side. There are there are multiple way to call your do your data set in the RStudio. One is you can type the data here itself. You can write your own data in this window itself, or you can save it in CSV file, SPSS file, Excel file. So in general, we will get all our data sets in the Excel or CSV format only. So now I am going to tell how to use these icons. So that will be very helpful. Instead of typing each and everything, that will be difficult for the non-statistician. So I'm going to tell you how to import and export data using these icons. Okay, and basic R commands like filter and muting and descriptive statuses, how to calculate. So this session is fully based on the how to open data set, R code and data set, and how to export these data in a different format, and how to use all the function. Okay. So is it visible? This is file. This is file. Are you able to see? Now it's visible, right? So the file, from the, if you go to the file, you will get new option, new file option. So if you want to write a new script, click new file and click this R script. So you can write, you will get the new window. In that new window, you can write whatever functions you want, whatever your data you want to import or export, you can write the commands in this R script itself. Okay. Now I am going to import the data first. Okay. So import data here, import data set. If you click here, from the text or read our function or Excel file, SPSS, SAS, data. So all you can save your data set in a different softwares also. So these are the statistical software. So statistician usually save SPSS or Stata or SAS format. In general, everyone use the Excel format. So now I will click Excel. So it will ask where to get your data. So if I give browse means, it will ask me where your folder is. Now I'm going to use desktop MLMG workshop. I have some data set. So I will use that data set itself. Sorry. Here. So already this software has the install package called read excel. Okay, like I'm calling that package using library function read excel. Okay, and it's providing the name itself wide data, and from the read excel, from this path, take my wide data and view this wide data. Okay, if I click import, see, so you are getting ID with the data set consists BP1, BP2, BP3. So like this, you have to import whatever data you are going to analyze. Go to the particular import and take the appropriate format and import, then you will get the data set name here itself. So throughout this analysis, this data will be called wide data, and whatever function you are going to do, like summary of this data. Summary of this data means I will give summary of wide data. This wide data will be analyzed throughout this process. Okay, now I have imported the data. So this is the basic thing. Now I'm going to give how to use a basic or how to use a basic R function. So I have created the R basic codes here. I shared with you all. I think Madan Anna will share with you in the mail. After the break session, you can work on your own way. So now I will open the R basic code. R basic. So already you receive, I think you will receive the code thing. Just check your mail and download it with yourself. One second, don't open it. Madan, I think there is this one is missing in the dark thing. We will write it after the session. Okay. So now I am creating the, now don't look at these packages. I will tell you. First, I'm creating one data frame with ID, name, age, height, weight. So this is my basic data set. But here I have only 6 observations. Okay. But in real life scenario, it won't be like that, right? So to run all this function, like if I want to calculate the age, mean age, average height, average weight, if I want to calculate all these things, means I need this function, dplyr, this deployer package I need. So if I install that package, this one, I will run this package and I will call this package using library function. If you uh, not aware of this install that package function, means you can use this window and write type dplyr. You will get that package and install it using here itself. No need to type install that package. In generally medical people, they won't aware of this install that package. We need to type these kind of things. For them, it's very easy to type it here and the package will show it here. You need to install it based on the commands. Okay. Now I will run this code. This simple less than an hyphen, this arrow mark representing the data has data.frame id equal to this, means id will comes under 1 to 6. Name equal to means all the names will called as name tag, age is age tag. So all this called in the tag of data. So when we are assigning whatever function, we will use this assigning symbol, this one, okay, are equal to.
Vectors to form a matrix or data frame. You can, is it okay? This is an easy way of doing it. Each one is a vector. ID is a vector, name is a vector. Then job is easy to combine everything. It will become a data frame. This is to demonstrate a small example. Usually you will enter your data in Excel or any other data frame or SPSS, then you can import it easily.
If you call your data, so it will comes in the data frame format. Okay. Now I want to going to do some kind of like I want age less than 30 or age greater than 30. I want to do some kind of filtering. Filter function is used to give like a conditions. You can subset. You can give the subset like be here height is less than 1.60, means I can give that subset function. Instead of using subset one particular data set, you can use filter for giving some function less than or equal to or greater than whatever condition you have. You can give that condition after data comma the condition. Okay. Before that, I need to attach this data. I didn't run the package, so it's showing error. if I not understanding what is this filter, in the filter, what are the things I need to give, I'm not understanding this function means, in general, or if you give help filter means it will show what are the thing you need to give input, what are the input we need to give it in that filter function, it will show. In our studio, in this package, question mark, the package and the filter, double colon and the filter means it will show what are things you need to give. I just take this thing. So you need to give the data and what are the function you need to give, it will explain with the examples also. Okay. The next thing is general age of the patient. When we are typing the thing, we are giving age. Sometimes we will take the caregiver age also. So that time patient age, caregiver age. We can rename the age thing. So using the rename function. Rename function is helpful to change the variable name. For that, you need to give the data. What changes we are giving, participant age equal to age. Okay. Fine, yeah. Now it's changed. Okay. The similar way, when in your Excel sheet, you will mention your Excel sheet, you will call the Excel sheet as a data. Okay. In that, whatever variable you are giving, and if you want to change that variable name, you can give rename the data name, and whatever the tag you want to give the tag name and original variable name in the Excel sheet. Okay. The next function, mutate. It's very useful function. If you want to add one more variable based on your already existing variable. Now we have height and weight. Okay. We can calculate BMI. In real life scenario, you will get the height and weight or any other observation, you will get the raw data only. If you want to calculate from that thing, you can use the mutate function. The mutate function is helpful to add or create the one more variable or more variables, or you can remove one variable also. Okay. So I will run this code. Now look at the mutated data. See, so the BMI is added. Now I just want to remove age from this data set. Yeah, but the rename age is what I have given, data underscore renamed. Okay, I will show. But here I given data. Now instead of data, if I give data underscore rename, now see the difference. See, whatever data name we are giving, assigning name, I'm not using. For your understanding, I just given data underscore rename. That is, this thing is stored in this particular data set only. This mutated will store in this data underscore mutated. Okay, I'm not changing in the original data set. See, that is a good thing. Whenever you are doing some calculation, whatever thing modification you are doing, don't save it in the original data. Create one data set and then save it in the thing. So you won't lose your original data sheet. Otherwise, you can do one thing. You can add these changes in the data set itself. Use data dollar rename, that kind of thing. Like rename, visually we don't use, but in the BMA, if you want BMA into your data set, I will show you. So now I am adding the data mutated into the data set, okay, the original data set. See, original data set as ID, name, age, height, weight, but the data mutated has ID, name, the same things with the BMI, weight. So whenever you want to add additional variable, use that data dollar symbol, the original data dollar symbol, and add those variables. Okay. Right. So now mutated thing we are doing. Okay. See the mutated data. Now I want to remove age from it. So if you give age equal to null, you can remove. So understanding this mutate function, what we have to do, the question mark, that package name, that colon symbol, and write this mutate, you will get what are the things we can given in that option. Okay, I'll show. Null, no way, yeah. So you can keep all are used, unused, none, before, after. So these kind of comments you can give using this mutate function. Okay. The examples also how to use all this code of the object used in this function. You can understand using these examples. Okay. The next thing, this symbol. This symbol from the df, this is kind of our data set. Okay, from our data set, this is pipe symbol. Okay, from this left side, whatever mentioned, take that left side data set and calculate mutate from this thing. Z equal to, like, x plus 1 is, so x plus y is 3, so consider z equal to 3, keep all, keep it all the way, yeah. So where we have to take this x plus y from this df. So this pipe symbol is dollar sign is different. Dollar sign before this symbol. Before the symbol, you need to use the dollar sign. Okay. After the symbol, to call the thing, sometimes the summary function, it won't work. Okay. Here we are using calculation. The next thing, usually we will get duplicate data set with name, ID, number kind of thing. So to remove the duplicate thing, distinct function was helpful. Okay, using this function, you can remove the duplicate rows. But in this data, do we have duplicates? We don't have. So shall we create one thing and check it's giving or not? So I will create 7, ID 7 or ID 1 itself. Yeah, we'll create ID 1. Names. Which one? That is see, colon, because it's a numeric. In the in our whatever SPS or whatever software you're using, in the numeric it suggests a numeric. No need to give single quotates and double quotes. No need to give. But the character string, whenever you're using string variable, you need to give single quotes or double quotes. Okay. We are creating duplicates to show the distinct function. Differing rows. Why? Now the 7th row is created. So we are going to remove the function. Now see data. So the duplicate row is removed. In the real life scenario, from the ID, from the starting itself, we will start from ID, patient ID. We'll repeat that ID and that patient details only will start. So the ID is very important. Okay. I have created new data, unique. Mm. Ah, did you run the library? This library. You run that library. If you don't have that package, run this one. Remove the asterisk symbol and run this. Install that packages. Okay. So whenever you are doing whatever analysis, you need to run the corresponding packages. Okay. Then only all this function will work. Attached data. Without attached data, it won't give. If I enter age, means it won't give the age data from the data set. If I give attached, means all the whatever I have given into here, I can call it whatever name I have given in the particular data set itself. If not attached, means you have to give the data dollar, the symbol. So data dollar.
So whatever the work you are doing in future, the data is that data. Okay. Otherwise, every time you need to say data.
Yeah.
whatever data you wanted to use. You don't have to repeat it.
Otherwise, you have to give data $age, data name.
Everywhere you need to give that.
Now we are simply using.
Wait a minute. The data is a file name. Maybe this is the wrong file name. Data means data. No. Say for example, J is a file name. JY $age. That means J is the big file name in which age is one of the variable. So every time when I say socioeconomic status, J $SES. So like that you'll have to give. It's to not avoid that, you can say attach J. So the following work is going to be J.
Any other job? Yes, the same thing. So what you will do instead of data.frame, read.x, I will show it in the next. Excel.
Do it and come back, do it and come back. So if you know a little bit of these things, then you can do it here itself. It's basically, it's called a data manipulation platform. Okay, say for example, subsetting, I wanted to take a random model with a smaller age group. And then you have to go outside and make a small file, bring it back and run. Instead, you can say subset it. Okay. And make it as a small file, rerun the code. So in a way, it is useful if you know the ABCD of some data manipulation.
Filter function. Filter function is kind of subsetting your data set. See, I will run this code.
So I want to data has male and female. I wanted to do analysis. I wanted to create a new data for males and new data for females. So filter it by male, filter it by female. Yeah, we call it as subsetting also. Okay. Filter subsetting.
If you give the view function, means it will create one particular another window and it will show whatever data is there. Or you can save it those subset into separate Excel sheet or CSV file. You can view it in the Excel or CSV format itself. So here I want to see the greater 30 only age group. So see, there are 3 people has above 30. Observe. Like intervention group, control group. If you want to see the 2 subset differently, means you can give intervention as greater than intervention equal to 1. So the next function is na.omit. When you don't have the data in the particular observation like age or a BMI or height and weight, you can remove that data and run the analysis. Okay, in the practical scenario, you won't get all the observation for the patient. So for GE or repeated measures, you need the complete data set. That time you can remove NA dot means the entire row will remove. If the one observation also missing means the particular patient, the row will remove from the analysis. 10 observations and 10 missing, all those 10 will, yeah. See, in our studio only, if you type means it will show what are the names we have in the data sheet. In our program, you won't get. You have to type it each and everything. That is the benefit using this one. See, the previous data, there is NA. So that is removed from here. The third row is removed. So run along with me. If you're finding any difficulties or the code shows any error, means raise your hands. Okay. So before running the code, we need to first check the package is available or not. Okay. Just run library dplyr. Run this code. Keep your cursor here and run. There is a symbol run with a green arrow. Keep the cursor in your seventh row and run it. Okay. Or control enter. Keep the cursor here, control enter. So the code will run it here. So any error? Anyone got any error? So the package is available in the system, right? Now run step by step. Run this. Keep the cursor here in the starting of 11th row and run. Keep the cursor in. No need to select all the thing. Just keep the cursor in the starting point of the 11th sentence. Okay. Run it. So anyone got any error? Now attach the data. Run the data 20. Are you able to run? So did you attach the data? The next one, filter function. You are going to do the filter function. I am attaching the data. Now it's coming the following object are masked from data this. So repeatedly this thing is showing this warning or something because I am attaching the data in multiple times. So it's attaching again like that the message is showing here. Okay. So are you able to run the filter function? See the filter data. How to see the filter data? Just type data underscore filter. Type data underscore filter. Are you getting? Is it running, sir? Running? Oh, where is the data set now? Yes, sir. It's running. Okay. So now run. So data filter.
So we have like
Data.
okay. So when we have to
Just run.
yes,
Type data filter.
where we
Anywhere. You type it here means you need to run. I will tell you there. Okay. 1 second. So we run the command. We have to see the data, right? So you have to type it here or here itself. Okay, I will type it here. See, I have the data. So what we have to do? Run. Okay. So the result will be showed here. I hope we are all in the same page. So are you getting the result? Okay. One thing here for this commands, I am not giving that asterisk symbol, but here I am giving the asterisk symbol. Why? Anyone has any idea? Yeah. This is kind of information for us. Okay, so if you run this also, it won't show any effects here. We won't get any result. It's kind of a title or message for our understanding we are giving here. Before, if you give asterisk here means the data, it won't run. It will run, but it won't make any changes in the filter data. Okay, the asterisk symbol before if you are giving means that command won't execute whatever function we are giving inside. Okay, this asterisk symbol. The next thing, data renamed. Okay, run the data rename. So are you able to run? Are you getting the result? Similarly, we will run everything, mutate, run the mutate and see the mutate data set. Create a modified column, this one. And the muted thing, what we are getting? Extra one more column with the name of BMI. Okay. Getting us? Are you getting sir? Hmm? Yeah. Are you getting that? Yes, sir. No. If you want to give age as age of patient, participant age, like BMI, sometimes you will get caregiver's age also. That then differentiate the age groups or gender. They will give the detail labeling for the age. So that situation, you can use this function to explore different function. Now we are giving the rename function also. You need to type in. You have to type it now. You have to type the name. Data underscore muted. You have to type it and run it. Then you have to call this. You have to give this one. See, once you run this code, data mutate, assigning operator, mutated this function, then you have to type it, data underscore mutated. Then only you can see the changes in the, what changes happened in the data set. You need to call that data set. Then only you can see the data set, okay? If you're not running this, the code will run, but you can't see the changes, what happened in the function, you can't see. Okay, when you're calling only, you can see the. What is the next function? Unique. So remove the duplicate, right? Now run this data and type it data underscore unique. Then only you can see the changes. What happened in the unique data underscore unique? The distinct. This function is removing the duplicate ID. Okay. See, there are 7 IDs here, 7 observations. The 7th one is duplicate, so it's removing the duplicate. So everyone got the result? Yes. Then na.omit. There is one na in the data set. So the row 3. If you give na.omit means it will remove the entire row. Which row has the missing? Any one observation also is missing means it will remove the entire row. So run this one, clean the underscore data. That also missing. If you give empty also, if you're not entering also, when you're importing the thing in our program, it will give NA or empty. So it will, if you give NA dot omit that situation also, it will remove. Okay. I hope we all run the na.omit. Are you getting? So the next thing is very important. That unique is we are not removed from that unique data set. Okay. See here na.omit I have removed in the original data. Okay. If you want to remove from this data underscore unique means you need to give data underscore unique. Mutated data means data underscore mutated. So the what data you are going to analyze in that particular data, you need to remove that NA observation. Okay. Yes. One is equal to one is double equal to.
No, that will actually run a true or false statement.
No, here.
Yeah, this is working. Okay, this is working. But this is not working.
Unexpected equal symbol in this area that's showing.
This two, the difference is this data overlays.
Did you attach the data?
Yeah.
Then no need to give
Yeah,
here.
I know that. So I used to
Ah.
like this.
Oh,
Okay, this was like this was actually working after even after I attached data and all the way.
I will check and let you know that. Okay. After the session, I will. Okay. So the next thing is very important. When you are doing any, you collected the data in the first phase, then you want to have more details from the patient. Okay. So that time you completed all the data collection and the entry, everything is done. So you imported the data in the, for the analysis perspective. In future, you want to add more variables like their family details or any other clinical variables. If you want to add means, you need to use the merge data set. Okay. In this, you need to keep in mind the ID should be same. If the patient number 1 is coming to you, you are giving 101 for the patient number 1 and you are collecting some observation for the day 1. And the next week, the same patient is coming, the ID should be 101. And you are collecting different measurement like their blood samples or any other measurements, different measurement you are collecting. So ID should be same. You are going to merge the different variables here. Here we are going to merge the different variables. In the real life scenario, survey and all, when you are doing survey and all, if you want to add the additional variables, you need to keep in mind the ID should be same for the patients. Okay. So here the data which has the ID, gender and country. Okay. We need to merge these data set into our original data. We already have, what are the things we have it in the data? The original data. The data, our original data as ID, name, age, height, weight. We have all these variables. But now I want to add their gender and country. These two variables only I am going to additionally add. But what thing is common? ID is common. So what is the function is used to merge the data? Merge function. Okay. The function called merge is used to attach the two data set. So run this code and see what happened. Okay. Is it running for you? Or any error? Error? Why? Did you run the data one? You need to run the data one first. You need to run this data one first. So merge our original data and our new data is data one. Data comma data one. By what I am going to merge? The unique ID. So by ID within the codes. Okay. Yes. The new thing. Mother from the CU they send some. This is second part. Before that one mail. Served on the mail part 2. Part 2 mail. Now he is sending. So are you getting the result? Are you able to merge the data set? No. I'm not understanding Hindi. Double quotes. So by within double quotes only you need to give that common ID. Okay. So this is the first scenario. The next scenario, we will append the data set. We will add the new patient, right? Once you completed the 100 patient, you will stop the study or whatever it is. And 20 more patient or 10 more patient, you want to add that data also into the analysis. That time append the data set. So you are adding the rows. Previously, you are adding the columns. For the same patient, you are adding the more variables. Here, you are adding the patient, the whole sets you are going to add. Okay, that is the difference. Merging is adding more variables. Appending is adding the new patients. Okay. So the new patient is 789. New participants ID and their name, corresponding age, height, weight. Okay. So the function called R bind. The function called R bind. The previous thing, merge function we use, no, we can use C bind also. See, R bind means row bind, C bind means column bind. We are binding the two things. Okay. But sometimes in the data.frame, C bind won't work properly. So that's why we are using merge function. That we have to be very careful. Okay. Now I'm adding the more patient using the function called R bind. Okay. Adding the new patient using the function called R bind. Okay. So now run this code and see the data set. Are you getting the result? So the new 3 patients were added. And here the duplicate data only is existing because I have given data. Yeah, original data. If I give data underscore unique means it will remove this one and give 9 observation. It will, yes, comma. Here if you give comma na dot omit, if you give means equal to true. Na omit equal to true. If you give here means it will omit the na thing also. Or you can write it down. So Na is removed. Here also. So now I want to add one more variable to show C bind is how the C bind function is working. So I created a group 1, 2, 2. You can give whatever you want, but here previously 9 observation because I worked with the unique data. Just give comma one more. How many observations you have now? 9 or 10? In this 10, in your R code, you just check how many observations you have. Yes. Nine or 10? Na dot omit? 10. So in the group, how many observation you have? 9. Just add one more. Comma 1 or 2, whatever you want, you give. Add one more. Okay. You understand? See here 10 observation, but in your thing 9 only there. You just add one more group. No, number is missing. You just comma 1 or 2, whatever you want. You just run so. See by number of rows 7. So 7 rows only there. Run up and data. How many observation you have? Check. One, two, three, four, five, six, 7, 8. 9 observation. Am I right? In the group, in a group, how many observation you know? Are you able to run the code or not? You getting? See by you have to run the group. Run. Run. Now run the mutate. This one. You check the number of observation. In the group, how many numbers are there? Check. You remove NAS. That is unique. You need to use a unique data set.
If any is in it.
Unique means duplicate. To remove the duplicate. Nivi is duplicate. You can use unique. NA dot is NA dot omit. There is only NA data is there. Yes. Here. To remove. I'm just creating group intervention and control group. Okay, to give a no, don't do this one. Okay. See, I think some people are not running the DA1 data set. So it will show the different rows. Did you got the result? Did you got the result? 9. So you have 9 observation. The group thing you need to run the muted, the second one. This one run the. Oh, show error. You have 6 only, but in the group 9, you have to run the. Please run the all the codes, then only you will get the result. If you miss one data set detail means also you will get the error. I'll show what error you are getting. See, I removed one observation from the group to show what error is there. Okay. One observation I removed from here, but I have 10 observation, but in the group variable, I have given only 9 intervention group or control group. I have given only 9 observation. So it's showing 10 rows, but you have given 9. So it's not correct. For some people, it will show 7 here and comma 9. So you have seven observation in your data, but you are created with the 9 observation. So please run all the data set from the start. Like you need to run this data 2, data 1, everything. Then only you will get the equal numbers. Otherwise, you can, for time being, you can do one thing. Whatever number here it's showing, change accordingly. Here. Here 10 means I have 9 only. So I will give, if I give one more number means it will equalize, right? If you have 7 means you just delete 3 numbers from this group. I understand? If you are getting error 7 comma some number means 7 comma 8 or 7 comma 9 means remove 2 numbers from this group. Okay? 7 comma 9 or 10 means remove 2 numbers from the group. Or 10 comma or 9 comma or 7 comma 6 or something. The less number you are getting here means please add in the group. Please add some 2 more numbers. You need to get the equal observations. Okay. Yes, sir. You have any doubts, sir? You got error? Okay. You have to call the data mutated. Are you getting now? Are you getting now, sir? Are you getting now? So are you getting the thing? Yes. Okay. So for me, one observation is less in my group variable. So I'm adding that one number here. Now see it's equalized. Now see the data muted with the so merging, appending, everything is clear now, right? Then I want to see the what is the mean age, height, weight, this kind of thing. Okay, I want to see the mean summary statistics for this data set. So just give summary of this data mutated. What you are getting, just type or run the thing. So the first thing ID. So for summary data means whatever inside the data, it will provide the summary. If it is a name, it's a character. So length of the name maximum is 10. So it's giving 10, length is 10 and class character like that. So it's a ID. We are not worry about the ID variable. So what is the average age? So minimum 20, maximum 40 and their median age is 32. Similarly, height, weight, and group also we are not worrying about. Standard deviation is not giving, right? You can give. So in page number 20 in your book, page number 20, please open page number 20. Please open page number 20. There is a slide Descriptive statistics. Are you able to see this page? To run summary statistics, you need to use the summary tools function. So library of summary tools. Okay. Package. Yeah. Okay. And descriptive DESCR give age. You will get the age, mean, standard deviation kind of thing. So it gives mean, median, standard deviation, IQR, skewness, cutoff. General summary will give the mean, median, first and third quartile, the overall, the distribution of your data. Summary tools, it's not visible. Huh? In the book also it's there. You just check the book, page number 20. Page number 20, R session. In the package, it's not available. It's unit install. So you will get the message summary tool successfully. So sorry, summary. So now the libraries. Okay. Now just give descriptive of age. See, if run the package summary tools descriptive of age, so it will give all the measurements. So it's mentioned in this book page number 20. Okay. If you have any doubt also, you can go through it when you have time. So similarly, if you want to see the distribution of your data means what function you have to give? Summary of data. So it will give the first quartile, second, third, median. So previously we just give the general average, standard deviation, median, whatever. But now you have an intervention group and control group or male, female. You want to see by the group wise. If you this code is not available in your code, I will explain it to you. You have the exercise for this also in the regression part. Okay, in the afternoon session. Here, I will explain the code, please. Group wise descriptive statistics. Here, what is my data name? Mutated. So here my data set, I'm calling my data set data underscore mutated. That is the first step. Then the pipe symbol. This symbol, why we are using the symbol? From this you take all the whatever I am giving after this symbol, you take it from here. The first thing I want to give the thing by group. So group by, this is the function group by, then variable name called as group. What is the variable name in our data set? It's a group. Within the bracket, we are giving our original variable name. This is group by is a function. From this data set, take the group variable. What I am going to take, what I am going to do summarize. What summarize? I want count how many numbers. Count is how many numbers. So count equal to. This is general way of mentioning the data, the variable names. I'm going to give count n of. N of is the function. How many numbers are available for this intervention group, control group? That n of, this n of. Then this is the mean of. See, page number 20, you have given this mean of, SD of, mean, median of, kind of function were given in that page number. The same function only you have to use. Before this equal symbol, you can give mean underscore age or m underscore age or median underscore age. Whatever tag you want to give, you can give. But after this, it's a predefined. Already the R code has the function names. You have to use that function only. If you are giving capital M mean, it won't work. Capital SD, so whatever function is R provided, it is predefined. You have to use the default strings or character, whatever R has. Okay. So mean of age. Na.rm. Na.rm is Na.rm you need to remove. That is equal to true. If the data has Na means remove. If it is false means don't remove. Keep it as it is. Okay. Ni.omit. That also you can use. Same. Okay. See here, then SD of age, height, weight. So here we are going to see total N by group.
Exclude all the cases, even age does not have data, it excludes the whole case. And another case, gender is not available, it excludes that. So globally, it is done for a file. But yeah, here it is a na.rm.
The particular age.
Particular age variable. So if I have 10 cases missing age out of 100, so the mean will be calculated for 90 observations. This is variable specific information. Is that okay?
Yeah. See here, if 2 data is missing means for 98 cases only it will calculate. But here the height is available for 100 means the 100 observe for the 100 observation only it will do. For the na.omit, it will take overall. So for each observation, each variable, if you are giving na.omit means it will remove the particular variable only. So here we are going to take the descriptive statistics for age, height, weight for these 3 variables. So mean, standard deviation, mean, standard deviation. Then print summary of the data. Could you run this code? Just type it and run. After this, we are going to see the which data. Yeah, you just type it and just type. Because this is very important function, you are going to use the t-test and whatever after G repeated measures, and you are going to use this only for visual representation. Also, this will be helpful. That's why I'm asking to type it here. Okay. Is it visible here? Whatever. After this, we are going to see wide to long, long to wide format. That is our exercise here. Then you apply all the descriptive statistics, whatever you learned here, you just apply for the data. Okay. Groups underscore summary, assigning operator, data underscore mutated, this symbol percentage greater than percentage. If you type itself, it will show the thing in RStudio. Okay. The symbol group by group underscore by. So I think everyone run the task group summary statistics for by group wise, right? You are the code error, package error, the package error also. After this wide to long, we will run. I have 1, 2, 3 people. Some issues with the package. After this, we will. So when you have a repeated data, like the same patient with the 2-time BP or 3-time BP or their BMI, whatever measurement you are collecting in a different time point. So that you how you will enter the data, patient number 1, their corresponding measurement in the row wise only will run. Wide to long. When you are in the analysis perspective, we won't use the wide data. We will convert this wide data into 2 columns. ID is common one, the BP measurement and what are the time points, time point 1, 2, 3, 4, whatever it is. So when you have the repeated data, you will melting these different columns into 2 columns. Okay, different multiple columns into only 2 columns with the variable called the common variable BP and with the corresponding time points. So this is the restructuring the data set from wide to long format. Okay. Here wide to long format, there is a function called pivot longer. Okay. This function is used to convert the data into wide to long. Okay. One more function is also available, reshape function. That is also widely used, but this is very easy to understand. So that's why we are using pivot underscore longer, this function for the wide to long format. Here we have one example data, but now we are going to work in the real data. So I will show it here, then we will work on our original Excel data, how to do it wide to long format, importing data from Excel and how to reshape the data set. Okay. Here ID BP1, BP2, the same data frame format. Okay. This data is called wide data. The name we are giving wide data. This is the package TIDYR, TIDR, TIDYR, whatever name you want to call, you just call TIDYR. This is the library. This is the function for wide to long format. So this pivot longer is available in this package. So before reshaping the data, you need to make sure that this package is already installed in your R program or not. If not, means you need to install using the install dot function, or that install window you need to type it and install. Okay. In this now my new data set name is called long data set. So I am calling the first I'm calling the package, then long data, new name I'm giving for this data, give the data name as long data, assigning operator using this pivot long underscore longer, this function. I'm taking this wide data, mentioning this wide data. In this wide data, column starts with BP. In this Y data, comma, columns, start with BP. What variable is repeating? That variable. So here BP, in some cases, any other measurements, right? BP, start columns start with BP, starts underscore with. Okay, here everything is underscore, pivot underscore longer, starts underscore with. So what is the variable we are given? BP. Suppose here SYS, systolic BP means we will provide SYS. So here what should become? SYS. So whatever name tag you are giving, use that name tag here. Then names to, names underscore to. What my long data should be looks like? Dot values. Values will take from this BP, take the values 96, 98, 85, 88, whatever is given, take that. And time point, based on this 1, 2, names separated, names underscore separated. What is separated? This 1, 2, the underscore. So separate the time from after the underscore. So it takes, if you have more than 2 observations, means 4, 5 means it will give 1, 2, 3, 4. So this is the format for the wide to long format. Okay. So you need to give the function name and what way data we are going to convert. You have to give that conversion data, and column name, whatever name you are given for the repeated measure, that name character only you need to give. And what are the names you are going to give? Dot values. Dot values means from this BP dot values, take that values, time point from this separated 1 and 2. How many time points? Okay. This is the general format. Similarly, wider, pivot wider, underscore wider. ID 1, 2, 2, 2, 3, 3. When we are repeating the data set, this data set, ID 1 has 2. So 1 and 1 as time point 1, 2, 2 different observation. ID 2 has 2 observation. So ID is repeating, right? So in the wider, now the long data set we have, but you want to see the wider format. I don't want to see the repeated measure 1 time point. I want to see separately. Like that means you need to convert this data into long format. This is available in page number 18 in your thing. Okay. In your booklet, page number 17, 18 is talks about long, wide to long, long to wide thing. Okay. ID 112233. So the repetition is there. Time point, what is the order we have given? The time point and the BP measurement. The same package, and pivot underscore wider. This is the function. What data we are going to see? Data equals also you can give, otherwise just long underscore data also is fine. No need to give. Names from, what names from? Time point. Time point only we are 1 and 2 we are converted. So that is the names from C. And values underscore from BP, where we have to take the values from the BP only. So we are mentioning. In the BP, prefix, suffix, prefix. In the front, BP underscore only, time will come, right? So just we are mentioning. In some people, they after the all the analysis performed, they want to see original data set back. The long format means everything, every time it will repeat it, right? The ID, time, everything will repeat it. That time, if they want to see only one time point observation means they will use, convert this back. But you can use it in the long format also by time and by observation. If you give it in the analysis, like previously we done no group by summarize, like that also you can give it using the long data itself, but it's more difficult for the non-statistician. So each observation, if they want to see is separately, means they will go back long format itself. But in the long format itself, you can do the separate time analysis also. Yeah, here for hypothetical example, we are created here, but in general scenario, we won't in I'm working in a mental health organization. We have SAPs, SANS. These all calls are positive, negative symptoms kind of thing. In a 2 years follow up, 6 months, 6 months, 6 months follow up. That time you have multiple variables and you have different time points also. That time we can't type it like this. We will call the Excel sheet or SPSS sheet and convert wide to long. We'll do the analysis. For here, hypothetical example, we have provided here. But you can do more variables in a different time format also. You can do wide to long, long to wide. Okay. Yeah, that only we are going to do. Okay. So this is clear. Now we are going to do wide to long and some summary statistic you are going to do, then long to wide. Okay. I think everyone got the mail. Okay. There is exercise one wide to long R file. Please check. This is file available in your sheet. Exercise 1 wide to long R file. R file. Okay. Exercise 1 R file. Are you able to see that exercise file in your system? Okay. Now open this file using the file open R script. So if you open the script means you will get this window. You will get this code. Or you will get without explanation, you have the code. Just tell me. Are you able to open the code? So this file, again, go to your folder wherever you store your data set. You go there. There's a Excel file called wide underscore data. This is our data. This data only we are going to convert wide to long. Okay. Don't look into this wide Excel, these codes. Don't look into these codes. Okay. Don't look into this code. Okay. Now I'm going to tell how to use this option by clicking and how to import the data by clicking. So that is very easier for the starting stage. Okay. Everyone on the same page? Shall we import the data? Okay. Go to file. Before that, just run this library read Excel. Run library read Excel. Is it running? So now file, import data set, file, import data set, and choose this from Excel. From Excel. Choose from Excel. Now you will get this window. Click this browse. Wherever you are downloaded your sheet, go to the particular folder. Now I have it in day 1 MLM workshop day 1 session 4. If you have it in download means you go to download. If documents means document, picture means picture. Okay. So click this wide data. So are you able to open that wide data? Just give open. See, once you click open, whatever the Excel sheet has, it shows here, and code preview. See the code preview. Suppose if you want to change this label wide underscore data, just remove data itself. It's not okay. So sorry, it won't work. So this is the code preview. You can change it here. Okay. If you change it here, no need to underscore data kind of thing means you can give it here, then click means it will give just wide. It won't show wide underscore data. For time being, we'll keep it wide data itself because our code has wide data only. Now click, see the code. The console window, is it visible? Is it not visible? So now see your R script. See your R script. Previously, I stored this data into downloads and wide data Excel. But for this workshop, I saved it here in the desktop MLM workshop. So if you are not sure about this path, you just go to the file function, import the data wherever you store, you just find the path and run means it will automatically provide the code. Now copy this code and paste it here. Okay. So in the future reference, you can use it again, right? So copy this and paste it here. I hope we are all on the same page. So this is a print wide data. Now I'm going to run the package. So pivot underscore longer. My data name is original data set name, wide format is wide data. Select the column which has BP underscore 1, BP underscore. It starts from BP. So I'm giving the character is BP and split the column into two parts. First part is BP. That should come. But underscore 1 should come as a second row wise, right? So time stores the second part 1, 2 as a new column. Separating this from underscore because our data has BP underscore 1, BP underscore 2. In some people, they will keep dot BP dot 1, BP dot 2. That situation, it should be dot. Okay. Shall I run this code? Please run along with me. Now see the code. Are you getting the result? So data converted as wide to long format. Okay. Now I want to save this data in an Excel sheet. Where I want to save my Excel sheet, the path, wherever you want to save, copy that path. Before that, if you don't have the right Excel, install.write excel. This write excel only to save our, to export our whatever data we have used here. We can export using the function write excel, write underscore xlsx. Okay, so run this package or just run the library. Is the package is available or not? Just check. Run library. Is it available? So before running this, you need to give the path. Before running this, you need to give the path. I will tell you how to give this path. Okay. I want, this is my folder where I am storing all my thing. Okay. Just go and click it here. You will get the path. You go here and click. Say once again, I'm showing here. You go here and click. So you are copying the, just Control C. You copy that path. Okay. Go to that folder, copy the path. And you paste it here. Just keep that long data as it is, because I'm going to call this data as a long underscore data only. Okay, so don't change. Just before the download d colon, just remove that thing and copy my new path. Whenever you are using the c colon the path, you need to give the double slash, double forward slash. Okay, you just give double slash. So did you copy the path wherever you want to save your data set? And did you give the double slash thing? So this should ask your path and how to save your data set. What is your data set name? Whatever you want to give, that name you need to give it here. Long underscore data. From where? This long data. Write underscore xlsx within bracket the data name. The name what we have run it here. Long data. This is our assigned name, right? This is our assigned name. So give that assigned name here, comma, within double quotes, select the path and put double slash it here. And the new data set should be called as long underscore data, or whatever you want, you can give. I'm just going to change long one underscore data to show the difference. Okay. I am giving long underscore one. So I will run this code. Now go and see your folder. See, the data was created in my path. Is it running for you? Is it not running? Check. If it is not running, means check the path. Double slash should be there. When you are copying the path, it will give single slash only. See. If you click it here, it will show single slash only. You need to give double slash when you are running the R code. Okay. Check if the code is correct or not. Double quotes with comma within double quotes, double slash at the end, the data set name, whatever you want. No need to give the same long data. You can change it like a BP underscore data. I will show again. You can give BP long data. Okay. Here, whatever you want, you can give the names. See, the BP long underscore data is created. Okay. The last option with the dot xlsx, you can give whatever name you want to give. You can give it with the time, date and time also. Today is 30 May, May 2025. I created this data. Your run means Now see. Are you able to run? You getting? See, whenever you are running the data set, you can create with the date. It will be very helpful. The last date which you have, that is your last working data set directly, like that you can choose. Okay. Similarly, you can save the code also like that. Save as whatever name you want, the study name or project name, you can give that name underscore date. Okay. So why too long? Any doubt? Are you able to run this codes within double quotes, please? This long data from your new converted data, comma, within quotes, the path till here it's a path. Please look here. Till here it's a path. This is whatever name you want to give, you can give. Okay. Till here it's a path. In this path, I am going to create one BP long data with today's date. Okay. So till here, you need to copy the path. In that path, you will get only single slash. Use again, add one more forward slash, otherwise backward slash, single backward slash also you can use. That you can use only single. If forward means two slash. Okay. Within quotes. Don't forget. So now, are you able to do it? So go to the folder and you will get long to wide code. Exercise 2, long to wide code. Exercise 2, long to wide code. You open it. Instead of using this, what we have to do? We have to get our new created long data set. How to go for that? File, import, Excel, file, import Excel, browse. So I have created different names, long one, BP, long data, BP data underscore with the date function. So whatever name you have given, click that data set name and open it. Okay. I'll use long one. See, long one data, read underscore Excel, path and view the long data. Now I have imported my long data. Okay. So if you want to copy this path means you can copy and paste it in the here. Okay. Then I will save the data sheet, the script. So now we are going to run this package and similar way the wider, this is the function pivot wider and the data set name is called long data from, sorry, here I have given long data, but what is my data set name is called long one underscore. So whatever name you are giving, give that. Okay, here. So do the changes. Okay. Then the time point, values from what? Values from, values should be taken from the BP and prefix we need to give the BP underscore or BP dot, whatever thing you want, you have to give BP underscore 1 you want to get or BP dot 1, whatever way you want to see the different time points, you have to give that. So run it. Now see the wider format. Yes, sir.
if you have time independent variables like gender, age, so what is the command that they should also be put as
Keep
one of
it.
the just keep.
Yes, keep.
Yeah. Just
So-
tell them that. Or we can find out after, later on we can do it.
Yeah.
Just go ahead.
Okay.
That is also very important.
Yes, sir. So now you can take one data set in that same sheet, cholesterol BY is there. You can work on with this data. Don't make any changes in this data. Create one more data set with a different name and work Y to